All right, looks like we're
This is live. What is this?
Okay, so we are doing our Hangout. This is actually kind of a fun one. On the way up to Halloween, a couple weeks beforehand, we get to see a lot of Halloween costumes, and I spy a couple in little preview boxes. So this is going to be fun. This is our show and tell, which we do every week at 7:30 p.m. Eastern Time. We're here in the Adafruit factory. Look at this awesome view. You got the wide screen. You like it's? I think there's more now.
That's right.
You got the wide one.
Yeah.
So you
more
can
pixels.
See more pixels. We're here at the Adafruit
Same
factory.
Price.
Manufacturing. I'm dressed up as Lady Ada. This is dressed up as Mr. Lady Ada. And we're going to call on you in the order we see you. We got to get out of here at 7:50, so please let us do that so we can get ready for the next show. It takes a couple minutes. But we'll start off with some Adafruit peeps.
Yeah.
Let's kick it off with peeps.
All right, Tony D, what you got going on this week?
Yeah.
Hey, real quick, I just wanted to hype a guide and a really big important thing that we did earlier this week. So we released MicroPython for these boards. This is the Arduino Zero and the Feather M0, and it's basically the SAMD21 Cortex M0 microprocessor. Fancy name for a more powerful but still low cost and really good value microprocessor. So it can run MicroPython now. You can do things like digital I/O, analog I/O. Check out learn.adafruit.com/category/MicroPython and look for the SAMD21 MicroPython guide. That'll tell you how to load the firmware. It's in beta, so we're still finding out like little issues and things, and not everything is supported. But we think this is going to be cool and a useful thing. If you've done Arduino, but you like high-level languages and you want an Arduino-like board or experience, then keep your eyes peeled on MicroPython for this. You'll see more.
Okay. Right, and we'll also check out the latest video.
Yeah.
Oh, yeah, right. Yeah, so I did a video Monday, where I went through how to load it up, so check that out. Watch Tony D's desk.
All right.
Okay.
All right, thank you, Tony D. Next
Sweet.
up, Don Pedro.
Don Pedro.
Hey, hello, everybody. How's everybody doing? So I'm going as Fix-It Felix's evil twin brother, Fernando, because I have a black shirt on. Yeah, so actually Kirby's he's over there. Is he over there? Probably over here.
Yeah.
One of these, he's here. And this is all his fault, so. Hey, he put together an Instructable not too long ago, and I got inspired to do something similar. So I took the idea and I was like, hey, it'd be cool to add sound effects to the hammer, because we all know Fix-It Felix got a hammer from his old man. So I have an Adafruit sound effects board inside the handle. So I got a couple sound effects in there. The speaker's mounted to the actual head of the hammer, so I had to route some wires through there. Yeah, so it's all 3D printed. There's no finishing work done on it because it's printed in gold PLA. And the cool thing about the sound effects board is you can add all sorts of different buttons or even accelerometer, maybe even the vibration sensor. So if you wanted to hit something, it could actually trigger it. But it's really loud. So I opted in for the button because I just like the like not triggering it by accident. So that's why I like the button. Kind of works for me. So I'm going to be, like I said, Fernando. But I also 3D printed the patches. So on my hat here, I have this printed in Ninja Flex. And it's 2 colors because I just swapped the color out, which is really easy to do. And then I sewed it to the hat.
The blue matches perfectly.
Yeah, it matches really nice. So there's a guide and a video out on the learning system, so you guys can check that out. And the kind of goal is to get cosplayers inspired to add sound effects, see how easy it is. Because it just there's no program required. You just plug it into your computer and you can upload sound effects, OGG files, WAV files. Yeah, and Peter's got something cool.
Yeah, so I also got a costume for my drone. We turned it to like a little UFO. Might be a little bit too bright, but super simple little mount that you can attach to the landing gear and turn it into a little UFO. That's totally too bright. Turn that off.
Okay.
No, I got it. See?
Oh, yeah. Woo.
Oh, there you go.
Oh, man.
Just turn it off.
No.
It's
So
gonna
this
be
is
so loud turning on.
Phantom 4, right, from DJ.
Yeah.
This is great.
And it's just running the default animations on there, but it totally looks like a tractor beam, especially if it's foggy outside. You have that flyby and scare some of the children.
Good.
Yeah.
All right.
Super simple build and just enough clearance so it's not going to mess with your vision positioning on the bottom here, and it has enough clearance for all of the camera to move around there. So super simple. We'll release a video for that in time for Halloween next week.
Cool. That's kind of what drones are made for.
GoPro UFO. Yeah, this is
Scaring children. Okay.
scaring children. Like, if you can't scare children, why purchase it? Okay.
All right.
Thanks, guys.
Steph, John Park.
Hey, John Park.
Hey, so I just released a new guide this week, and a video, which is the Mad Science Test Tube Rack. And I want to talk a little bit about the origin of it, which was I did this sort of thing. Let me turn off the light overhead here, where I had some quinine water and I lit a UV light under it and it glows like crazy. So I decided I wanted to make a sort of spooky prop out of that. I went online and bought a whole bunch of little pigments that are different colors of UV reactive powder, mixed them up with some water, and made myself a whole little set of multicolored fluorescing dye. And then I went and built this, which is, I'm going to reposition my camera here, the test tube rack. And I'm going to turn that on.
Spooky.
Yeah, so I've got a Feather microcontroller and the terminal block Feather shield on that. And I'm just running 13. I'm not doing anything fancy with multiplex or anything. I'm just running 13 LEDs off of the 13 pins on the Feather. It's pretty straightforward. And I happen to have let me turn the lights back on here so you can see this. The little stoppers that go in the tops of the test tubes fit a 5mm LED perfectly. So I've just got the stopper with an LED in the top. Got a bunch of different colored dyes in there, and I've got a kind of fancy little semi-random, semi-deterministic blinky pattern. And let me see if I give you a little more light. You can see this is all made of the black half-inch gas pipes that you can get at the hardware store and a little flange, and I've bolted it to a little piece of wood. So it's a very sturdy but straightforward kind of build that doesn't require any 3D printing. I did make my little test tube holders out of some black acrylic that I laser cut with this kind of Gothic pattern. And I also made this little holder for the Feather out of some laser cut acrylic. Those parts you could substitute for other black pipe, like little elbows and holders and T-slots, and get the right size test tubes. But that is my Mad Science test tube rack, and we're going to have it on display when we do our little get-together for cocktails and cider and so on around Halloween.
So are you going to, when it's cocktail hour, are you going to replace those with gin and tonics? Because that has the
that's
quinine.
the idea.
Yeah, that's cool.
I do have somewhere, I got like a molecular cocktails book and set a few years back, and it came with a food safe glow in the dark powder.
Oh, cool.
And a food safe UV fluorescence powder. So I do have the capability of making a couple drinks beyond the quinine and tonic.
Okay.
All right. Well, you have.
It'd be really funny if they got sick and then threw up and it glowed in the dark. No. Bad idea.
Now we have a new goal. So go check out the guide and
the competition.
The video if you're interested in finding out more and you want to make your own. I'd love to see some rebuilds of this. So go out there and make some cool glowing stuff, people.
Okay.
All
right. Phil B.
Okay. Hey, Phil B.
Hey there. Friday published a very, very simple little guide, Circuit Playground, no soldering required. It's basically a simulated flame that uses the NeoPixels on the Circuit Playground and a battery pack, and that's it. And you can stick it in your pumpkin. I don't know if we got the light here to see it.
Oh, yeah.
Yeah, stick it in a jack-o'-lantern, or paper lantern should work really good for that. Or if you have a Halloween costume or item that needs a decent fire effect, it's not too shabby for what, 30 lines of code.
Yeah. Safer than a candle, too.
Yeah.
Yeah. Oh, yeah. Definitely. You're not gonna, burn your house or your pumpkin down.
Okay. Cool.
Yeah, the fun guide, though, I explain a little bit about the math behind it, because I always liked that part in tutorials.
Yeah.
So check it out.
Yay,
All right.
dragons.
Thank you so much.
Flaming dragons.
Okay. Next up, another Felix. Stuff with Kirby. How you doing?
Good. So I made a binary game that gives you a number in binary. Then you have to flip the switches up or down for the correct value. And then you would press the button, and it lets you know if it's good. So I got the laser cut wood today, so I haven't got a chance to wire it. And then I put the instructions on the back.
That's cool.
Oh, it's like a little learning game where it's like, you have to learn
Yeah.
binary to.
Yeah. And there's easy mode where it's only 0 to 15, and then there's hard mode where it's 255 to 0, I believe. Yeah. And then I got it in an Autodesk circuit simulator here. So right now I've got the switches to the left for 1, and I press the button. And it tells me it's correct.
Hmm.
If it was wrong, it would just say try again, and then I could move them around. So that should be 10. Yep. Then it grabbed the new number. And then I drew it all up in Autodesk Fusion before I printed it out, so I could make sure the stuff would line up right before I printed, and then had one cut in wood. So went together pretty good.
It's a really nice
All
drawing.
right, that's a cool project. And
I
there's
didn't even know
plenty of
Circuits.io did simulations.
there's plenty of room on the back for an As Seen on the Show and Tell sticker. So
Yeah.
email support@adafruit.com and we'll send you out a sticker. Oh, do you have something else to show?
This is just about 4 pounds of plastic so far. It's from a 3D Kit Bash.
Oh, wow.
520% scale of a normal Barbie doll.
All right. I like the
I was
eyeball.
gonna put
Yeah.
Yeah, that's
the teensy eyes in there, but I got to work on it a bit to make a better holder inside the eye.
very cool. I like it. All right.
That's creepy.
Next, Richard. Richard. Oh, you're gone.
Wait, Richard the Tube.
Richard, you're back. All right,
Hi,
Richard,
okay.
how's it going?
Hey guys, so I know.
Hey.
You're good.
Hello.
There we go. All right. So yeah, I know I haven't been on for a while, but we've been doing a lot of stuff here at the Makerspace, including some classes. And actually, just this last week, we had a bunch of people over from the cosplay and costuming community to talk a little bit about integrating technology into costuming. And that was we had like a lot of turnout in spite of the really bad storm that we had here. And we talked a lot about just even basic LEDs that can be added to cosplay. And what people are really interested in was talking about putting sound in there. We had a couple of people who had projects they wanted to put sound in, and they were looking for like the typical wave shield that you put on the Arduino. And I showed them your guys' effects soundboard, and every one of them was like, "Oh man, this is exactly what I need."
Yay.
So yeah, it was really well, and like I was actually surprised a lot of people didn't know about it in costuming. So now they hopefully do. And then we talked a little bit about some of the stuff I've been working on with the gesture activation with LARPing weapons, and that went over really good. I've been teaching some of that stuff with the Circuit Playground classes that we've been getting booked over here. So that's going over really well as well. And then, of course, I have my Halloween costume, which I'm kind of working on. I'll have it done actually a bit early, so I'm looking for tomorrow, having it pretty much all done. This is an upgrade of a continuing costume that I have of kind of like the radioactive zombie boss. And every year I'll like build up certain skills that I'll have in doing costuming, and then I'll incorporate those skills in Halloween into this outfit to make it better. So this is the newest edition with all the lighting stuff I've been working with. And this is using a whole bunch of NeoPixels. And then, of course, you guys will recognize those 3D printed spikes. These are done partly with NinjaFlex and flexible TPU. And it's got my chip in it. So as I move my arm, more of them will light up. And then it goes down to a flicker. And then, of course, the tube. Which this was kind of like a warrior zombie outfit, but I think it kind of looks like something out of Mario Brothers, or like some Mario Brother warrior type thing.
It's like Bowser, like armor, because he's got the spikes a little bit.
Yeah. So we're going to actually go to a local haunted house here in Seattle this weekend and probably part of next weekend to do a lot of scaring of people.
Good.
So hopefully I'll have some pictures of the finished outfit well before Halloween.
All right, sweet. Nice update.
And we'll be talking about this one at a convention we're doing a panel at, which will be, again, about incorporating more manufacturing with 3D printers and stuff for cosplayers.
All right.
You're a walking example.
All
Okay,
right.
thanks, Richard.
Thanks so much, Richard. Next up, Kit. Hey, Kit. How's it
Hey,
going?
Kit.
Unmute your mic and show us your project.
Hey,
Hello again.
so it's been a while, but I was at Micro Center and saw one of the Adafruit screens, and I thought,
Yay.
hey, I just have to do something with it. So I 3D printed this old looking TV set.
Oh, that's cool.
Adafruit, like 5-inch, like with touchscreen backpack.
That's
And,
great.
Oh, how did you do the lens? The lens, it's rounded.
It's not. It's just like a 3D printed part over it and
An illusion.
Oh, it's an illusion. Sorry, it looked like it had a glass lens. I was like, how did you 3D print that?
I wish.
That's
But
cool.
no, it's just a real distortion effect, and I thought I was thinking a lot of the the Pie Girl stuff, but I thought I'd do something a tiny bit more authentic.
Yeah.
And that's like how big the TVs were when we were kids too. Like
Yeah,
they
that
really
was-
did feel that small.
Yeah, you had to get close.
All right, that's awesome.
All right, excellent work, Kit. Well, there's room for a show and tell sticker if you want one.
Yeah, that's cool.
Yep. You still
All
there,
right.
Kit?
I think he muted.
I think Kit.
Okay.
Yeah.
Oh, you're
Okay.
back. Hello.
So yeah, that's it.
Okay.
Okay.
All right. Thanks so much, Kit. Email support@adafruit.com and we'll send you an SC on the show and tell sticker. Next up, Ron. How's it going, Ron?
Hey, Ron.
Hey, how you guys doing?
Yo, we're doing good.
All right, so I work for a university, and we have our wireless network, as you'd assume, everywhere. But it's segmented off such that certain things like gaming devices, IoT devices, things like that, they join a separate SSID. And students who walk around offer tech support, and we've had issues in the past with them not being able to find the MAC address of a smart TV or some one-off smart media device. So 2 weeks ago, my boss came to me and asked if there was a way that we could kind of make that easier. So I said probably. So I poked around a little bit and I remembered so I combined a feather saw with a Featherwing OLED board and put it in this neat little battery case I kind of hacked up a little bit. Initializes and broadcasts an SSID, which I don't know if you can make that out, but it has a specific SSID.
Yeah.
Tech help.
Yes, and so your device connects to it. It says client connected, and then it gives you the MAC address. Of the
Oh, so smart. That's so
and
smart.
that's all you have to do. There's no password. You just join it. But I have it half disassembled. So little rechargeable battery in there, the Feather Huzzah, and the OLED board.
That's
And
cool.
the neat thing about this battery case is there was already a little switch built into it. So I just desoldered the wire that was on there, soldered it into the LiPo battery, and there you go.
That's so smart.
Excellent.
I like that project.
Thank you.
Is that documented anywhere?
I got I was kind of asked about it a week ago, rushed to make it, just finished it last night, so I will document it. I'll get the code up on GitHub and all that.
Yeah, please
Okay,
do,
yeah, and
because
send us
this is something that I know a lot of people would be really interested in. That's so useful.
Yeah.
Oh, okay, yeah. I'll make sure it's documented and I'll let you guys know.
That'd be awesome. Thank
It
you.
should come with like the the really expensive routers and things.
If you
that
have a Samsung TV, it's going to take you an hour to find the MAC address.
Yeah,
it's like,
That's the problem we've had, yeah.
into the menu, submenu, submenu,
yeah,
submenu.
but if you
It's-
manage a campus, like this is something you'd think the providers of the equipment would have.
like
as a
every
thing,
IT
so-
manager,
Yeah.
they need one of these and the skull of
The
death.
skull thing is
Yeah,
nice,
the skull.
All right,
And the
Ron,
great
well,
thing with this is just, I think $40 in parts tops and,
exactly.
And it's
a week to
perfect.
build, so.
Yeah, and it's a good project
Cool.
for the students too. Like
Yeah, exactly.
All right, Ron. Well, thanks so
All
much. Email
Thank you.
support@adafruit.com, and there's plenty of room for a sticker there. And
Will do.
Aiden, how's it going? Play us out.
No, we can't hear you. You're quiet playing.
Can you hear me?
Yeah.
Sound great.
Hello.
So you may have noticed that in the past few show and tells, I've been kind of interested in making like soft passive materials that have interesting properties, like this one that you got to play with at Maker Faire.
I totally got to. It's awesome.
This kind of one. So I've recently created this one this past week. That's really quite cool. It's made of silicone here. I 3D printed this mold for it and casted it in silicone. And when it's compressed, it does something really interesting. So if you can see, it kind of crumples in this really consistent way, where it's made up of these elongated ovals that are rotated 90 degrees to each other. And as a result of their geometry, they like to compress along their shorter side than their longer side. And so as a result, they kind of all crumple up in this predictable manner. A very similar thing with a slightly different pattern was done first by a bunch of researchers at the Harvard Weiss Institute, I believe. However, I've kind of just replicated their work here. And I'm not really sure about applications for this. I was kind of thinking like crumple zones in cars or something along those lines where you kind of want controlled crumpling like this.
What's interesting is usually when you squish something, it bulges out. This doesn't.
Yeah. So, and the thing is, it's a square, and it actually reduces all the sides of the square equally when it compresses in that manner, which is quite interesting.
I had different types of particles that I wanted to let some through some of the time and some through the other. I don't know if that would work.
It could also be good if it's like you have to insert some sort of mesh or covering into a cavity, like for medical usage. You probably want to squish it like that and then release it, and it pops out evenly in all directions. That's I mean, Weiss does medical technology. So that would be pretty useful because you don't want it to like go everywhere. You want it to be like squish out, squish in.
Yeah,
very cool material.
And I've also realized that it's very close to this kind of idea in materials engineering that's kind of considered like a holy grail of material science, of a material with a stress-strain curve that strains very little at first and then strains a lot and then strains very little. And although this doesn't really show that, I think that if I were to make it out of a more rigid material, it would compress normally for a bit and then do that crumpling. However, that needs more testing. I'm trying to make it out of different materials. Like this is one that I tried making directly out of NinjaFlex, directly 3D printed. So I'm just doing some experiments with that and these kind of smart metamaterials.
Very cool.
Neat stuff.
All right. Well, thank you, everyone. This is an excellent.
And we finished on time.
Yeah, we finished on time. Thank you, Tony. Thank you, Seth Curry. Thank you, Ron. Thank you, Richard. Thank you, Phil B. Thank you, Noah Pedro. Thank you, and thank you, John. And thank you, Adrian. We'll see everybody next week, 7:30 p.m. Eastern Time, Wednesday as usual. And coming up next is Ask an Engineer.
See you in a couple minutes.
Bye-bye, everybody.